Dear students, today we will start chapter number 7, whose title is Non-Linear Equations. This chapter deals with the numerical solution of f of x equal to 0. You'll be given a function, an equation, and we need to solve that equation numerically to find the value of x. We are f of x. In this equation, f of x may be a linear equation. What is a linear equation? In which the highest power of variable is 1. For example, if you look at this equation, a variable x is using here and the power of x is 1, so this is linear equation. Similarly, in this equation there are two variables, x and y, and both have of power 1, so this is again a linear equation in two variables, and this is linear equation in one variable. If you want to solve this equation, for example, if we need to solve ax plus b is equal to 0, it will mean that to find the value of x. So how could we find the value of x from this equation? Shift plus b towards that side, so that will be minus b, and divide it by a, so that will be x equal to minus b by a. Linear equation, the solution of linear equation is very simple to obtain. That is very simple, and this is the exact solution of this equation. What does it mean? It means that whenever you replace x by minus b by a here, so you'll get exactly 0. You'll get exactly equal to 0. So that is the exact solution of this linear equation. Now equations other than linear equations are called non-linear equations. Probably these equations are algebraic equations in which the power of x may be negative, maybe in fraction, maybe x is in the square root, and so and so. So also exponential function is involving in these kinds of equations. For example, e power x. Trigonometric functions may be involved. For example, sine of x. Hyperbolic functions, for example, cos hyperbolic x. Logarithmic functions, for example, you need to solve log of x plus 2x is equal to 0. So these kinds of equations are called non-linear equations, and the solution of these non-linear equations is sometimes very difficult to obtain, and a few cases that is impossible to obtain the exact solution of those non-linear equations. So in order to solve those equations, we use numerical methods to solve these kinds of equations, and the solution which is obtained with the help of numerical technique is not the exact solution, but that is the approximate solution, that is nearly equal to the exact solution. So we are dealing with the approximation of the non-linear equations with the help of numerical techniques. Remember that. So we'll be using numerical techniques in this chapter to find the approximate solution of non-linear equations. And what are those numerical techniques? The first one is simple iterative method. The second one is Newton-Raphson method. Third one is the bisection method. The fourth one is secant method, and the last one is regular falsi method, or sometimes it is called method of false position. So we'll be dealing in these 5 techniques in this chapter to find the approximate solution of non-linear equations. Each of the method will be demonstrated, its idea will be given to you people, and an example will be solved to get the complete idea to understand these numerical techniques. So let us start the first method, simple iterative method. And that simple iterative method will be used to find the solution of f of x equal to 0. And f of x in this case is not linear function, because the solution of linear function is very simple. This function will be non-linear function. So f of x equal to 0. What are the steps to be followed in simple iterative methods? First of all, you will be given f of x equal to 0, a function, an equation will be given to you people, and we need to rewrite this equation in the form of x equal to phi x. What does it mean? We keep x on the left hand side, and the rest of the parts will be shifted towards right hand side, and that part is now denoted by phi of x. But restriction is there, that how could we write this equation in this form? Whenever the derivative of this phi of x, the absolute value of the derivative of this phi of x will be less than 1, and this inequality holds for all values of x in the given interval. However, this phi of x, we will find the derivative of this phi of x and then take the absolute, and we'll check whether this value is less than 1 or not. Secondly, initial guess will be given to you people, that initially you need to start the question by putting a special and initial value which is denoted by x naught, that will be given to you people. Our interval x naught xn, in which the solution of this function is lies, this interval will be given to you people. And the third step is we need to rewrite x equal to phi of x, this equation. We need to write this x equal to phi of x in the form of xn plus 1 is equal to phi xn. What does it mean? It means that we need to replace x by xn on right hand side, and we need to replace x by xn plus 1 on left hand side, and then we will put n equal to 0, 1, 2, 3 in this equation to get the required approximations. Or we may say that the number of iterations, the number of approximations is actually called the number of iterations. So first of all, we need to put n is equal to 0 here. We will be able to find x1. When we put n equal to 1 here, we will be able to get x2, then x3, then x4, and so on. Now, how many iterations are needed to find the solution, approximate solution, with the help of iterative method? So that is the step. Stop the iterative process when two consecutive values of xn plus 1, this xn plus 1, when two consecutive values of xn plus 1 are equal to the desired accuracy. For example, if you are asked to find the solution, approximate solution up to 4 decimal places, so we will check whether two consecutive values of x are nearly equal to each other up to 4 decimal places. If you need to find the solution up to 5 decimal places, so we will check whether the two consecutive values of x are nearly equal to each other up to 5 decimal places. So that is a simple criteria for this simple iterative method. Let us solve an example. Example is find a root correct to 4 decimal places. Remember that, up to 4 decimal places. So we will continue the process, we will continue the iterative method to get the two values of x which are equal to each other up to 4 decimal places, and equation is given to you: x cube plus x square minus 1 is equal to 0. We need to find the solution of this equation up to 4 decimal places, and it is given to you people that the actual root of this equation lie in this interval. In this interval the solution of this equation lies. So it means that this is x naught and this is x, and anyway this is x naught that is given to you. Solution is given that this is the equation, and this equation is in the form f of x equal to 0. This whole left hand side is f of x is equal to 0. So this is in this form. Now we will write this equation in the form x equal to phi x, x equal to phi of x. So how could we? First of all, we have shifted this one up to towards right hand side, and then x square is common in these two, and then we divide this equation by x plus 1 to get this equation, and to get this form we need to take the square root on both sides. So square root of both sides is x is equal to 1 by square root of x plus 1. So we see that we have written this equation in the form of x equal to phi of x. This is phi of x, and this is the form x equal to phi of x. So this is phi of x. Now we will check whether this phi of x fulfill the condition that absolute value of phi prime x is less than 1 or not. So let us take the value of phi of x, this is phi of x, and differentiate this function with respect to x. So that will be phi prime x, and this will be derivative of this function. This function is written in this form by shifting this denominator towards numerator. So that's why the power of x plus 1 is minus 1 by 2. Now using power rule to find the derivative of this function, power down, power minus 1, and simplifying this function, we will get this thing. We see that here is a negative sign, and this is phi prime x. We need to take the absolute value of phi prime x. So what is the absolute value? It means that we'll ignore this negative sign, because this is the absolute value of phi prime x. So negative sign is ignored, and just look at this interval 0 comma 1. The root lies, solution lies in this interval 0 comma 1. So between 0 comma 1 there are many numbers. If we take for example a number, say 0.1, 0.1 lies between 0 and 1, 0.2 as well, 0.3 as well. So whenever we put any value between 0 and 1 right here, and replace x by for example 0.1, and calculate this fraction, so the answer of this fraction will always be less than 1. And just look at this thing. If you ignore this whole function and look at this 1 by 2, 1 by 2 is actually 0.5, and we know that 0.5 is less than 1. So phi prime x, the absolute value of phi prime x is less than 1, and this inequality holds for all values of x between 0 and 1. So this phi of x, which is this thing, this fulfills the condition that the derivative of this phi of x is less than 1, and the interval is given to you 0, 1. Compare it with the x naught xn, so you will get x naught equal to 0. So x naught equals to 0. Now we will write x equal to phi of x in this form. We have just studied that. We will be writing this function in this form. What does it mean? We need to replace x by xn on right hand side and x by xn plus 1 on left hand side, and the last step is we need to put n is equal to 0 in this equation, n is equal to 1, n is equal to 2, n is equal to 3, and so on. So first of all, let us put n equal to 0 in this equation. Xn plus 1 is equal to 1 by xn plus 1 square root. So whenever we put n equal to 0, we will get x1 on right hand side and x naught on left hand side, but x naught is given to us, that is 0. So 0 plus 1, 0 plus 1 is 1, and the square root of 1 is 1, so that is 1 by 1, which is 1. It means that x1 is equal to 1. Now replace n by 1 in this equation. So on left hand side we will get x2, that is x2. On right hand side we will get x1 plus 1, so that is x1 plus 1. But x1 is 1, that is x1. x1 is 1, so replacing this x1 by 1, and that is 1 by square root of 2. Calculating this value with the help of calculator, we will get 0.7654. Now put n is equal to 2 in this equation. We will get x3. x3 is equal to 1 by x2 plus 1, that is x2 plus 1. But x2 has been calculated 0.7654, so that is 0.7654 plus 1, and with the help of calculator this value is 0.7526. We see that these two values of x are equal to each other up to 1 decimal places, but we need to find the solution up to 4 decimal places. So we will check the two consecutive values of x that are equal to each other up to 4 decimal places. So in the same manner, calculating x4, now x4 and x3 are equal to each other up to 2 decimal places. Now whenever calculating x5 and x4 are equal to each other up to 2 decimal places, and then x6 and x5 are equal to each other up to 3 decimal places, and whenever we put n is equal to 6 in this equation, we will get x7 is equal to 0.7549. now x6 and x7 are equal to each other up to 4 decimal places. So these two values of x, x6 and x7, agree up to 4 decimal places. Therefore the required root is this same answer, which is 0.754 and 9. So that is the criteria for simple iterative method, and this is very simple to understand. Now we are going to use calculator to use this simple iterative method. That how could we calculate these values? Now from here we have got a calculator, Casio calculator. We need to put this function in the display of calculator, writing xn plus 1, denote xn plus 1 by say y. Not necessary, but just for time being. So this is say y and this is x. So we are going to write here this is y, then equals to, then there is a fraction, and numerator there is 1, and in denominator there is a square root, so that is a square root, and writing x plus 1 in the square root, so that is x plus 1. So we have written this function in the display of this calculator. Now we just need to press calc button. It will ask you about the value of x. Now this x is in the first iteration, this x is x naught, and x naught is given to us, that is 0. So we will press 0, so x is 0, and press equal sign. So you'll get y is equal to 1. So you see, this is equal to 1. Then press equal button. It will ask about the value of x, and the new value of x is x1. That is the previous value, and this previous value is actually the answer of this equation. So we will press answer is equal to, that is square root of 2 by 2, converting it into decimal notation, that is 0.7071 7071. That values goes a bit different. Correct it. Okay, correct this value. Now again press equal sign and press answer. You will get 0.76536. That is the value actually, 76536. We are going to calculate the answer up to 4 decimal places. So up to 4 decimal places, if you see here, up to 4 decimal places, this value, this 3 will become, because this number is greater than 5, so this value will become 4. So that is 7654. Now again, if you want to fix your calculator up to 4 decimal places, so press the shift button and then the setup button, and fixes it up to 4 decimal places. Now you see, this answer is now up to 4 decimal places. Now again press equal sign and answer. You'll get 0.7526. Again equal answer equal 0.7554. Again equal answer equal 0.7548, this answer. Then equal answer equal 0.7549. Again equal answer equal 0.7549. So see, these two values are now equal to each other up to 4 decimal places. So this is how we use the calculator whenever we are dealing with the simple iterative method.